In this video, we're going to learn more about vectors. First, let's talk about vectors as we saw them in an earlier video. The idea of a vector was something that had magnitude and direction. And we didn't really do a whole lot with them at that point in time, but we'd say if you wanted to travel at, say, 300 miles at a bearing of north 30 degrees east, this is considered a vector because we have both a magnitude, the 300 miles that we're traveling, as well as a direction, north 30 degrees east. But it was really hard to do work with vectors back when we wrote them as just an arrow on a piece of paper. If you wanted to combine, say, two vectors, you would draw your first arrow, you would draw your second arrow, and then you would have to figure out what this arrow that combines both of them is, and you have to use your trigonometry to get the answer, and it's fine, but that was the only way we had to work with them. And that was kind of a lot of work to do to get the answer. The new way that we're going to work about vectors is something called the component form. So here's the idea. We're going to say, okay, instead of giving a magnitude and direction, I'm going to say for this vector, I want you to go equivalent of 3 steps to the right and 4 steps up. This then becomes the vector, which we'll draw as bracket 3, 4, end bracket. So component form just says, give me two numbers, one that tells me how much to the right we went, the other tells me how much up we went, put them in our angle brackets like this, and this then represents the arrow that goes the equivalent of 3 right and 4 up. If I wanted to say, what about the vector that is -1, 2, that means I would say, look at what's happening here, start at whatever point you're at, go left 1, go up 2, and the arrow that goes that direction and that length, that would be the vector -1, 2. So again, this is not the same as the point 1, 2. They are different things here. One's just a single point in the plane. The other is an arrow drawing towards that point. And now we can write vectors in terms of these component forms rather than having to give a magnitude and an angle separately. Now you might be wondering, okay, this is fine. We have these vectors here, but where's the magnitude? Where's the direction? Well, to get the magnitude, what we do is we're going to do something like the following here. We're going to put what looks like absolute value signs around the vector. This means magnitude. And we're going to use the Pythagorean theorem. It's going to be the square root of 3 squared plus 4 squared. And the magnitude of that vector is 5. So if you ask yourself, how long is this arrow here? It would be 5 units long. If I want the magnitude of -1, 2, that would be the square root of -1 squared plus 2 squared. This one would have a magnitude of square root of 5. Notice that if we don't have specific numbers, but we're calling like a variable name for our vector, let's say our vector v, to indicate it's a vector, we normally put a little arrow on top here to indicate it's a vector. And then if we wanted to take the magnitude of it, we just write what looks like absolute value of v, ending the arrow there. So we can talk about the magnitude of specific numbers, or we can talk about the magnitude of an arbitrary vector, and we can still use the same notation here. And then what's great is if we want to add and subtract vectors, we don't have to try to draw arrows and combine them and use trigonometry to solve for it. If I want to add these two vectors, I can just add them one component at a time. I look at the first component, is 3, and the first component of the second one is -1. 3 plus -1 is 2. Then look at the second components, 4 plus 2 gives me 6. And lo and behold, we get the answer very, very quickly on adding these two vectors. So this is one of the biggest strengths for writing vectors in this way, is that you can add and subtract them with ease. If I want to say subtract these two vectors, we can just go ahead and say 3 subtract -1 is 3 plus 1 is 4. And then 4 subtract 2 is 2. So these two vectors subtracted would be the new vector 4, 2. Another thing that we can do with vectors is we can do something called scalar multiplication. And scalar multiplication is when you take a number, which is not a vector, this is called a scalar, and you multiply it by a vector. And the nice thing is just distribute in as if you imagine, like parentheses, 7 times 3 is 21, 7 times 4 is 28, and we have this new vector here. And what scalar multiplication means is if you take a vector, and then we'll call this a vector v, and then you multiply it by, I don't know, say 3 here, what that means is you just take the vector and make it in the same direction, but 3 times as long. And that would be 3 times v. So when I multiply by 7 over here, I have a new vector that's in the same direction as the previous vector, but it goes 7 times as far in that direction. Notice this also works with dividing by numbers. Let's say I have a vector and I multiply it by 1/2. That means you're going to have a vector in the same direction that is half as long. The last concept for this video is the idea of unit vectors. So a unit vector is whenever you have a vector whose length is 1 or a single unit. That means we want the vector that's only 1 unit long. So travel 1 mile in this direction. Travel 1 mile south. That's a unit vector. We will use unit vectors in many other contexts, especially in later classes. Multivariable calculus, as example, uses unit vectors quite a bit in that class because a unit vector can be thought of as telling a direction without having any effect on how far you're going, because you're just going 1 unit. So it's not like you're going 10 units, it might be 10 times too big. You're just saying go a single unit in that direction, and that becomes the baseline for saying what direction we're traveling in. Like for example, we say north, east, south, west, let's say north, there's kind of an implicit 1 in front of it, 1 unit north. And so unit vectors are a way to give directions for where we're traveling. And the nice thing is we can take any vector and turn it into a unit vector. So I could say find a unit vector in the same direction as the vector 3, 4. Well, we know that the vector 3, 4 has length 5. Because it has length 5, it's not a unit vector. But I want a vector that has length 1. Well, length 1 is 1/5 as long as length 5. So to make it a unit vector, I will just take 1/5 of our starting vector, and then becomes the new vector 3/5, 4/5, and you can check that the length of that is in fact 1. And so that would be a unit vector that has the same direction as 3, 4, but now it doesn't have any length other than just 1. So this is a quick rundown of the component form of vector and how we can use it to solve problems. And it really is the superior way of handling vectors compared to the magnitude and direction way that we saw in an earlier video.